So in this video, I'm going to go over the A/B test steps and also different methodology you can use when you're facing different situations in your A/B. So what is exactly A/B test? So imagine you have Amazon website and want to test out this button buy now, and it currently is an orange button, and you want to try, to see what would the different button maybe by the wording or by the color, but you should not change more than one thing at once for your treatment. And you want to test out how can we have a higher conversion rate for a different button design. And then so the example would be, and originally we have the orange buy now button, and now we want to test it with maybe a blue button or a different color, or just testing out maybe the words or something. So in your A/B test, you usually have your null hypothesis, which is your default assumption, is that there'll be no difference between the two buttons, right? That's their first condition, that they're the same. The second condition is that you don't know one will be better than the other. Maybe the blue one will be better than the orange one. Maybe the orange one will be better than the blue one. You have no idea. And the third condition is that you can potentially have one better than the other, and it can go both ways. It can be an orange button better to be a blue button, but it can also be a blue button better than your orange button. These like unequal conditions are what we call alternative hypothesis, and that's what you want to test out, is to see, are they the same or are they different? So these are two major things you need to know before you calculate your sample size. The first thing is to know, what are you expecting the difference to be between the two groups? It can be an absolute average difference, or it can be a percentage lift. And the other thing we need to know is the standard deviation of these two different groups. And you can simply calculate that with your SQL, as with syntax here with STDEV, which is standard deviation. And with these two numbers, you're actually able to plug into a formula in z-test, where you can just plug in the numbers and determine what your sample size should be. And actually, if you want to do like just simply conversion rate, A/B tests, then there are a lot of online tools that are out there. I'll have one of the links down below to help you, see how it looks like, but you pretty much just need a percentage lift expected, and it always defaults to 95% confidence, so that it will actually calculate a sample size for you very easily. So if you're using z-test for your A/B tests, it's very simple to plug in the numbers that we talked about in the previous slide and plug into this formula in the z-test, and you'll determine, so usually the z-score here will be 1.96, which is a 95% confidence, and you'll plug in your standard deviation, which is the little circle with the little head on it, and the squared. So you'll plug in the standard deviation square into the two groups. So the C here stands for control, which will be the control group in your orange button. Or the other way to do it faster would be just plug into your power analysis that you can run in R or Python, to just plug in your power z test and plug in, your expected lift and like the standard deviation, and it will just calculate it for you. I'm sure Excel can also do the same thing. I just haven't really used it much, so I would just plug into this formula to calculate the number. I will say the two most commonly used of sampling method to get your sample size would be, completely random. So you can usually do like order by rand parentheses in SQL, so that it'll be completely random. Or like a system generated random sample that you can get. Or you can, the other way of doing it is stratify random. So what stratify random meaning? You stratify your population into certain groups, and let's say you have 5 groups that you want to make sure you have a random sample from each, so that you have a good representation of the whole population, and that's how you would do it. So now I want to talk about the magical p-value after you have completed the A/B test, and that most people know that, we just use that 0.05 number to determine if we accept the null hypothesis or reject the null hypothesis. and that, just like, oh, it's less than 0.05, then there is a difference between the two groups. That's it. But I want to explain a little bit of more like why was in certain situation you would use 0.05 versus zero point 0.1, and what do those mean, and also a little bit of, like rejecting or accepting your hypothesis. Explain a little better. So when you use 0.05 or zero point 0.1, it's usually because the business, how important it is to make your business decision. So 0.1 is 90% confidence, and that you don't need to be as confident in your results. So it's like, as you can tell, 90% versus 95%. But you sometimes a decision can be made with less confidence because first, it doesn't have so much of a revenue impact or a business impact that you think that 90% is good enough to make a decision to move on to, actually make a change, compared to 95%, where it has to be something that actually makes a bigger business difference or a bigger revenue difference in your product that you think is very critical. And the other thing about, thinking about your null hypothesis and accepting or rejecting is that so true meaning your null hypothesis is true. That means there is no difference. So it's correct that you accept that there is no difference between the two groups, and that's a correct prediction. And then you have, rejecting the fact that there is no difference between the two, when there is actually no difference between the two groups or two different designs. And that's what we call a type 1 error, which is actually what you're calculating in your p-value to calculate, what's the probability of getting the type 1 error. And that's why when you have lower, when your p-value is less than 0.05 or zero point 0.1, then that's when you know that there is a difference between the two. And then the other thing is that when it's the null hypothesis false, meaning there is a difference between the two, but then you accept the fact that there is no difference between the two, and that's what we call a type 2 error, which is actually what you were calculating for your power analysis, which usually is 0.8 that most people would use, and that the power analysis is actually reducing your type 2 error. So I think most of people are very aware of, A/B tests done by the total, like, average number across the entire sample from your two groups. Which is, yes, that's very commonly used, and that's like most of the A/B test tools out there do. But when you really want to dig into your A/B test, there are actually a lot more things you can do. So, like, for example, you can do a quantile A/B test where you look at, instead of just looking at average of everybody, you want to see, like, how does this feature will improve in certain groups of people, so that you might see, the 75th percentile. So this is percentiles from 1 to 100. That meaning, for everybody, we assign everyone for a score, like a position of 1 to 100, and 75th percentile meaning they're the upper end of the 25% of the people who probably use your product the most, and we want to see, how does that impact this group of people at a 75th percentile compared to the median, which is a 50th percentile, and a 25th percentile. And now you can have an overview of, like, how does this A/B test impact at a different distribution level at different percentiles. And in your A/B tests, it's very common that you try to measure more than one metric for your two groups. Like, you might want to measure their click-through rate, their bounce rate, their purchase completion rate, and as three different metrics. But, like, if when you're measuring so many different metrics, it's very possible that one of them will be statistical significance difference between the two. But then, like, is that really correct, or are you just trying to increase the number of metrics you're including as many as possible until you can get one of the metric to be statistical significance? So I was actually asked this question at interview, and before that interview, actually, I've never heard of this before. But I guess it is something good to know that, that people tend to do, is that they try to get stat sig so badly that they just want to have as many metrics as possible to get stat sig, but maybe, you know, when you do that, you probably need to do some adjustments. And that's why we call this a Bonferroni correction, which is simply, if you're having like 30 metrics that you're measuring, you should not just use a p-value of 0.05, because that's very possible that at least one of them will just be stat sig, but that's not actually correct. You should probably, use the p-value divided by the number of metrics you're measuring, just so, you're not just trying to get stat sig for the sake of getting stat sig. And the other thing that's also very commonly used across all A/B tests is that instead of just testing A and B, you want it to be more efficient so you can compare everything at once. So you have A, B, C, and maybe D. Like this one, that you have an orange button, a red button, a blue button, and just try to see which one works the best. And that's also very commonly used. But when you try to calculate your stat sig difference for the score you're calculating, you should consider using a Donitz test. Maybe I'm not even pronouncing it correctly. But I did look up, what the formula looks like. It looks like you have to, it's like considering using a NOVA test within the t-test, which is super cool. And you calculate the score of like determining the statistic score completely differently, but it works pretty much like a t-test. So quickly summarize what I have talked about today. I've talked about, different hypotheses. You have your null hypothesis and no difference, and your alternative hypothesis that there is a difference. And then the way of calculating sample size, one is plugging into a formula with standard deviation and your expected difference and average, or you can run just a power analysis with percentage difference and your lift, or you can just use an online tool for your conversion rate. And then you can, the way of, calculating the p-value, and why would you even use a different p-value is because your business importance of this decision. And then the third last thing I talked about was a quantile A/B test. So instead of just doing your average A/B test, it might be a good idea to look at your whole distribution and look at your bottom 25%, middle 50%, the top 25%, and how they respond differently to your feature. And then we also talked about Bonferroni correction, which is for the case that you have like 20 metrics you're trying to measure for your statistic difference. And then Donitz test, where you're having multiple groups of tests, like ABC tests or something.